All right, everybody, welcome back. Today what we're going to do is we are going to factor polynomial functions, specifically using the grouping method. So if you take a look here, normally what determines what method we are going to use to factor a polynomial is the number of terms that we have. As you can see, we have 4 terms here. So that's what tells me we are going to want to use our grouping method. Now, what I'm going to do is I'm going to group my first 2 terms and then my second 2 terms. Well, actually, before we even do that, our first step in factoring should always be to divide out a GCF, anything that they have in common that multiplies into all 4 of my terms. Well, all of our coefficients are different. They're all even except for 5, so that means we can't divide out a 2. And not all of our terms include an x, so we can't divide that out either, and there is no GCF. So again, group the first 2, excuse me, and group the next 2. Now, if you notice, I grouped that positive, that plus sign, in with the second grouping. That is going to be important when we are dealing with negatives a little bit later on, but I kind of do that as a habit that we should definitely try to make sure that we are considering. So let's focus on our first grouping. I have 2x to the third minus 5x squared. What I want to do is divide out what they have in common. Well, the coefficients are even and then odd, so there's nothing there that I can divide out. However, they both have an x squared. So if I divide each of these by x squared, I end up with a 2x and a minus 5. Now I'm going to do the exact same thing with my second grouping. I have a 4x and a 10, and I can see that a positive 2 is going to go into each one. So I'm going to divide by 2, and I get a 2x minus 5. Now, what tells me I'm doing the right process here and is working the way it should be is that the values inside of my parentheses are the same. So now what I want to do is I'm going to picture this and imagine that is one term and this is the other. Well, what do they have in common? They both have a 2x minus 5. So I'm going to divide it out to the front, and that leaves me with an x squared plus 2. This is the factored form of our original polynomial. Now, whenever we do this, we might want to check to see if we could factor more. There is nothing that I can take out of this binomial, and this does not factor because although this is a square, this is not, and it's not a difference either. So that means we are done, and this is the factored form. All right, so that is factoring by grouping. I will do another example, and I'll also show you the box method on the next one. All right, so here's our polynomial, 8x to the third power plus 64x squared plus 12x plus 96. So all of these numbers, these coefficients, are a little bit bigger this time. So we want to make sure that we are trying to see if we can divide out a GCF first. So I need to think about, is there anything that multiplies into any of my 4 terms here? Well, my first thought would be 8, because I know 8 multiplies into 8, 64, and 96. But unfortunately, it doesn't multiply into 12. So that means instead, I'm going to look for another value, and my guess is 4. So if I divide a 4 out of each of these terms here, I'm going to end up with 2x to the third plus 16x squared plus 3x plus 24. So I'm going to keep that 4 in the front, but I'm not really going to worry about it at the moment. I'm going to group my first 2 terms just like we did before, and then I'm going to group my last 2 terms, and notice again I grouped that plus sign in there as well. So we're going to keep the 4 in front, but we're not really going to think about it right now. What I am going to do is I am going to try to divide something out of 2x to the third and 16x squared. Well, 2 and 16 are both even numbers, so I can divide a 2 out. Each of those terms also has at least an x squared, so I can take that out as well. So I'm going to divide each of these by a 2x squared, and I am left with x plus 8. Now, I'm going to want to do the same thing over here, and I have a positive 3x and a 24. The only thing they have in common is a positive 3, and that leaves me with x plus 8. Now, just like before, there's kind of a lot going on here, but hopefully I should see that I have x plus 8 inside both of my parentheses. So keep the 4 in front. We're going to divide that x plus 8 to the front, and that leaves me with a 2x squared plus 3, and this is my answer. However, remember, let's try to see if we can factor more. So nothing factors out of this, and again, this does not factor either, so we are good to go. This is our final answer. Now, what I would like to do is show you the box method. I'm going to show you the box method from this step here. Some of you might find this easier to do because it is a little bit more visual. It really is up to you. Whatever you would like to do works for me. Again, ask your teacher, make sure that is fine with them. So what I'm going to do is I'm going to set up our box, and I'm going to split it into 4 smaller boxes or rectangles. All right, what I want to do is I want to place each one of my terms here inside its own box. Well, the key part is my 2x to the third needs to go in the top left, and then my 24 needs to go in the bottom right. Other than that, it doesn't really matter where my 16x squared and my 3x go. So I could put the 16x squared here and the 3x there, or vice versa. It really doesn't matter. Now, again, we're using that area model. So what I want to do is find the length and the width that multiply together to give me this entire polynomial. Well, in order to do that, I need to look at smaller groupings of these values. So for example, let's look at these two values. I want to think about one value that is going to multiply into both of them. Well, the only thing they have in common is an x. And if that's an x, then what times x gives me 2x to the third? Well, my answer is a 2x squared. Okay, x times what gives me 3x? Well, my answer is 3. All right, so now we're getting somewhere. If this is a 2x squared and this box has an area of 16x squared, well, I need to think about 2x squared times what gives me 16x squared. My answer is 8. And let's double check that because this box has an area of 24, which is 3 times 8, so that checks out. So my factored form is I have that 4 from above, which I factored out as a GCF, and then I have a 2x squared plus 3. It's a positive 3 there, so that's why there's a plus, and then an x plus 8. And as you can see, this is the same thing we got over here. The difference is the order of these binomials, and that does not matter because we are technically multiplying them, and when you multiply values, the order is not important. Okay, so this is the traditional grouping method, and this is the box method. They both get you the same answer. It doesn't matter to me which one you use, but I would double check with your teacher. All right, last one here. I am going to do the grouping method first, and then I'll quickly do the box method as well. So again, divide out anything they have in common. Well, not all of our terms have variables, so that doesn't work. 3, 5 are odd, 12 and 20 are even, so I can't divide anything out there. Group our first two terms, and then group the second two, which I'll do in a different color. If you notice, again, I am grouping a negative in there as well. This is where it becomes important to remember to group in that sign with the second grouping. Now, if I look at that first grouping, I've got 3r to the third minus 5r squared. They have an r squared in common. So if I divide that out, I get 3r minus 5. Now, looking at my second grouping, I've got a negative 12r plus 20. So I've got a negative and a positive. Well, my first thought is I don't like to have a binomial that's got a negative in the front. See how this 3r is positive? So what I'm going to try to do is I'm going to try to divide out a negative. Well, negative 12 and 20, I can divide out a negative 4. When I do that, I get positive 3r, and then a positive 20 divided by a negative 4 is a negative 5. Well, here's a good indicator for me. My values inside the parentheses are the same, which tells me I am on the right track. So I'm going to pull that out to the front, 3r minus 5, and I am left with r squared minus 4. So typically we'd say, great, we are done. We've got our two groupings. But if we look carefully, this cannot be factored more, but our second binomial can. We've got an r squared minus 4. That's a difference of squares pattern. So I've got a 3r minus 5, and now I'm going to split this up into two smaller factors. Well, the difference of squares works by thinking of what value to the second power is r, so that's r squared, and then what value to the second power is 4. The answer is 2. So my pattern is going to be my a value plus my b value times my a value minus my b value. So that is our answer there. Okay, now I will show you the box method. The box method works here as well. I can set up my box. Again, the first term goes in the top left, and then the last term goes in the bottom right. It doesn't matter where my other ones go. I'll put my minus 5r squared here and my minus 12r there. So again, area comes from length times width. So I want to find out which two polynomials will multiply to give me the one in the middle. In order to do that, we take a look at smaller values. So I'm going to think about, okay, what goes into both of these? Well, 3 multiplies into 3 and negative 12, and they both have an r. So if I do that, I know that 3r times an r squared gives me 3r squared, and then 3r times what gives me a negative 12r squared. My answer is a negative 4. Sorry, that's a negative 12r. Now, if I know this is an r squared and this over here is a negative 5r squared, well, r squared is kind of my length here, and I need the width. R squared times what gives me a negative 5r squared. Hopefully, we all know the answer is a negative 5. And I can double check this. Negative 5 and negative 4 gives me a positive 20, which is correct. And this is where I get my factors of 3r minus 5 and r squared minus 4. So again, we should split this up, noticing that it is a difference of squares pattern. If you don't remember the difference of squares formula, again, you really could use a box method here. My first term goes in the top left. My last term goes in the bottom right. And now, because I only have two terms here, these two boxes, these two diagonals, are going to need to add to 0. Well, the good news is r squared only has r and r that I want to split it up into. 4 could be 1 and 4 and 1, but I know that they want to cancel each other out, so they need to be the same, which tells me that one of these is going to be positive and the other is going to be negative. Negative 2r plus a 2r is 0, and that cancels out. So this means my two factors are, again, r plus 2, r minus 2, and we can't forget our 3r minus 5. This is the exact same thing we got over here using our grouping method. So that is all we're going to do for today. The big indicator for factoring is the number of terms. So we need to make sure we are paying attention. If there are two terms, it could be the sum and difference of cubes or the difference of squares. If there are three terms, we are likely going to be in a quadratic form, or could be in a quadratic form, and could use our box method or our splitting the middle term or guess and check. And then if there are four terms, then we should be using our grouping or box method. Okay? If you have any questions, as always, please leave them in the comments below. Thanks for watching. If you liked the video, like and subscribe. Thanks.